Welcome, everybody. We're going to be working on Unit 1 tonight, and I'm going to be going through the PowerPoint slideshow here from uh, courtesy of Intel Corporation. I do want to flip over to our unit folder here just so you can see what we're working on. Unit 1 is basically kind of a little bit of a refresher in terms of what machine learning is, what it isn't, and kind of looking at some of the history and key players in the area. And really this will be kind of, I'll call it a bit of a review from the first course, but will also be a couple of new concepts thrown in here as well. First thing I'm going to do is let's get to the first content slide here. So we have the agenda, and really, I guess a good way to look at this first unit is it kind of does a quick overview of what the whole course is going to cover, in a sense, without going too deep into any one area. We're going to look primarily at what machine learning is versus deep learning, how those are used, right? So we'll look at some use case scenarios, and then what made this change and really become machine learning in the first place. So to the next slide here. We already went through some of these materials, so they have like stuff structured here. So like if you were doing the same training that I did, this, they use the same slideshows, by the way. These are some of the things that we're going to learn in the course. I am going to go through these quickly, by the way, because I know you can read these. You can pause the video if you really want to watch it in video format. The thing that I know always scares people, and I was having an interesting talk with a student this morning that was considering following this degree path, by the way, and I wasn't trying to talk him into it. And I'm like, well, you realize that there's math involved, right? And he's like, oh no, really? That's kind of a deal breaker. And I'm like, well, it shouldn't be a deal breaker. Math is a learnable skill, just like IT topics are a learnable skill. But we are going to basically look a lot more at how mathematical models and how statistics drives this stuff, because it's critical to it. We'll be working with Python. We'll be working with visualizations and a bunch of different machine learning algorithms. And for us here at a technical college, we're not that we're only worried about the technical skills, but that's where much of our focus is. But your critical thinking skills and these, societal skills will also come into play as well. That's kind of the format of how they do these courses. So here we go. All right, let's do a little bit of backtracking here and start looking once again at this thing called machine learning, understanding that it is a subset of artificial intelligence, one of the major subsets of artificial intelligence. And basically, they define it as a study of computer algorithms to make predictions based on existing data. That's like the fundamental aspect of it. So, in other words, we will create models, we'll develop algorithms, and then based on the data that we have, we'll make predictions as to what will happen. So you start thinking about that robot going down the Woodman's aisle and scanning the shelves. Is it artificial intelligence? Once again, I'll ask that question. Or is it automation? You might be surprised at what the actual answer is. By using stats, it aims to find a pattern in the massive amounts of data, and machine learning can do that more effectively than humans can, by the way, which is why we use it. And then if we see patterns develop, then we can create rules based on those patterns to make decisions. The rule is created from a pattern and not from programming it explicitly. So in other words, I'm not going to code a rule to drive something, for example, just because I want to. The rule is created based on the patterns that already exist in the data, right? We're not fabricating the rules. Notice that regular programming focuses on rules and data. Machine learning focuses on answers in data. This is where the difference is. So, in other words, we're operating from a base of knowledge with machine learning that we don't necessarily operate from when we're doing computer programming. With computer programming, sometimes we have to be explained the situation before we can write the code to solve the problem. With machine learning, the algorithms use the data that they have to find the patterns and use those patterns to create answers that we combine with other data to drive the machine learning. You see the difference? Right? It's a little bit more automated. All right, so they asked these questions. They also heard about AI and deep learning and what they are. So here's all the formal definitions that we have in these courses. So artificial intelligence mimics the intelligence of humans, basically, or other living entities that are autonomous and can make their own decisions or create or destroy or whatever they do. Machine learning is an AI technique where the computer learns from the data without specifying explicit rules, while deep learning is an aspect of machine learning inspired by our brains or neural networks. That's where it stems from. And deep learning also goes a little bit deeper. And we were kind of examining some of those things in the previous course, albeit on a superficial level. If you guys remember this type of graphic, well, AI is this whole big thing. Machine learning is the largest subset of it. And then deep learning is a subset of machine learning. So in other words, the deep learning stuff here also learns from the data without specifying explicit rules, but it uses different patterns, the type of patterns we develop in our brain, which they call neural networks. If we take generative AI and we throw it into this mix, well, that becomes a subset of deep learning. It goes even deeper into this structure, and it does combine many aspects of other areas of AI too, including natural language processing and computer vision, by the way. And we will do a look at like what generative AI brings to the table here in terms of machine learning. Remember the last course? Yeah, I'm sure you do, because it wasn't that long ago, just a couple of weeks ago, right? And the differences between these two areas, machine learning and deep learning. And please notice the acronyms, right? I have a hard time saying ML and DL personally, but I'm going to try, right, when I refer to these. Here's some of the differences between machine learning and deep learning. Notice, like, and you can read these on your own. I don't have to read every bullet to you, but for example, just the very first bullet, basically the number of data points, machine learning doesn't need that many to make predictions, where deep learning uses large amounts of data to make predictions. And that's kind of the difference. So which is going to be more accurate? Well, the one that it's got more data is probably going to be more accurate. Well, we assume, right? Hardware dependencies, machine learning doesn't need as much as deep learning. In fact, deep learning usually happens on server platforms out in the cloud, running on high intensity GPUs, that type of thing. It has gotten to the point now where personal computer systems can often run a lot of machine learning models locally. We can do that. It might not be as fast as the cloud, but it's possible, right? And I'm not sure you necessarily want to put your machine through that. And you can read the rest of these bullets. I'll let you guys do that on your own. But the whole point is deep learning is a much deeper subset, requires more computer power, more time, more data, more everything to do what it does. You guys recall these slides here from the previous course as well, but we talked about machine learning, where it came from, and notice that the first mathematical model of a neural network happened back in 1943. This is before we had the first fully electronic computer that was programmable. We had electromechanical machines, but somebody's thinking about this stuff before we even had the tools to do it with. And that always blows my mind. Then you start going through this timeline here. We have Arthur Samuel created his checkers program in 56. Alexei uh, did the first multi-layer perceptron. We very briefly talked about those in the last course. In 67, the nearest neighbor algorithm was developed by Peter Hart and Thomas Cover. And then we had Tim Cam Ho did a paper on random decision tree forests. And if you guys are like, what are all these things? These are different machine learning algorithms, basically. And I don't know if you guys remember, we had a slide that showed all the different possible machine learning algorithms or the popular ones, and there was like 100 of them. There's not a few. And then we just kind of keep going forward here. IBM Deep Blue won the chess game. Then Fei Li created the image database back in the 2000s. And then AlphaGo actually beat a human playing Go. And remember that game? That's the one that's way more complex than chess. And now they're teaching an AI how to beat humans playing that. So, you know, if chess wasn't bad enough, they're beating us at other games too. We were not getting into groups here, by the way. I'm just going to kind of talk through some of this stuff. So this slide's pretty superfluous, but are there other events that happen that are important in machine learning that aren't listed on that timeline? Oh, you bet, right? Tons of them, actually. A lot of them have happened within the last 15 to 20 years, frankly, more so than any other time period. So that's something you might want to research as you kind of move forward. There are some really important people that are in this area. And as with a lot of things in IT, real frankly, the people that develop these technologies often go unrecognized. Like, do you guys know who the developer of the internet was, or email, or any of that kind of stuff? Probably not. You know Mark Zuckerberg because he made Facebook, like whoever uses it. But what about this guy, right? And this particular person, his name is Andrew, by the way, and he goes by Andrew NG, I think is the thing, and I'm not sure if that's an altered name. This guy is an engineer that helped the Google Brain project. Also worked for the big internet search company of China called Baidu. I don't know if we talked about that company at all. So he was a system developer there. From there, he went on to work at Stanford and came up with the MOOC concept, the massive open online courses. And he's been teaching machine learning there at Stanford for a long time. So he's one of the preeminent. Very nice, Paul. Yes, and a MOOC is one of those like ways to take courses online for free, right? From big universities. And if you guys aren't aware of that, you should explore that. The other tip I'll give you with these PowerPoints, especially if you're not in slideshow mode, is all the information I just know is written into the notes section of the slide, right? So that's where the answers are. It says here in 2018, he launched and currently heads an AI fund, initially a $175 million investment fund for backing artificial intelligence startups. So he not only develops this stuff and teaches it, but also gives money to people going into it as well. Here's another guy, and I wonder, this guy's name is Yan Lu Kun, and I'm wondering if these are the right images. Because this name seems to match up more with the last slide than this slide. But anyhow, this guy's name, once again, Yan LeCun. I'm not sure if I'm saying it correctly. He's been around the scene for a while too. He's been working on stuff since the 80s. And he was the first one to train what we call a convolutional neural network system on images of handwritten digits. So like a lot of the stuff that we ended up using in the 90s as OCR software, for example, this guy had a heavy hand in it. Here's some additional people. And let's see if I can pull up their names here. Yashua Bengio is one of them. Jeffrey Hinton. Matthew Deering, Demis Hassabis. I hope I'm saying that right. All very key players in this area, by the way. And if you want to read up on them, you can either follow the links that you see on the slide here or look at the notes section to see what their role is. But it's always kind of nice to put faces and names to the people who are behind these technologies because they, once again, often go unrecognized. There's a lot of other really significant players too, and some of the ones they're mentioning are Andre Karpathy at Tesla, who does the AI for their self-driving cars, and Ian Goodfellow at Apple, Jeremy Howard at the University of San Francisco, amongst others. You know, there's a lot of key players if you're interested. One of the subsets, of course, of machine learning and deep learning, of course, is generative AI. Generative AI has kind of been where all the hype's been lately, right? And at the beginning of the course tonight, you know, I was encouraging you guys really should, if you're not playing a lot with AI tools, you should really start changing your mindset and doing that. Because I think what the future holds for most of us is those that are embracing the technology and know how to use it are the ones that are going to have jobs, and the ones that don't are, you know, aren't basically, or they'll be, you know, going back to the farm or something like that. So I think generally speaking, know what generative AI is. I don't think we need to really go through a lot of formal definitions here, but it is the branch of AI that perhaps scares us the most because it has the capability of creating things from scratch. And man, there's like all sorts of crazy Gen AI tools out there now. Everything from like, creating documents to writing computer code to generating images, to rendering video or creating music. Very interestingly, I went to a show. Oh gosh, I guess it was about 2 or 3 weeks ago now, right when the other class was ending, actually. And I talked to a videographer, and we started, I'm like, oh, cool, you got a cool camera, we started talking about video stuff. And then he started talking about that his company now, where they used to like manually create videos, are now taking videos they've created as a data point and using them to auto generate video that that either would have had to pay somebody to generate in the past or would have spent hours and hours and hours doing work. And it's very quickly transformed his whole industry just in a few months. He said that he used to spend sometimes days like working on like inane video footage, and now he just has the AI do it. Guess what tool he was using? You guys remember the Runway ML tool that we kind of exposed ourselves to? That was one of the tools that he was using. And I know that it's kind of a point of resistance for a lot of people to even try these things. I think a lot of the stuff that's generated by generative AI, especially artwork and music and stuff, I can tell. I don't know if you guys can. But it's going to get better and people are going to use it more. So now it's just a matter of like who's first to get it done or to do the new thing with it. And it's really kind of the point, right? Why do we have Gen AI? It just makes things easier. And I think about all the different things that I've been using it for lately, including, I don't know, coming up with course content. Or if you guys remember, I may have mentioned this during the intro to AI class. I was teaching Python stuff to my data analytics group, and I had one of the AI engines, and I forget which one it was now, probably Claude or ChatGPT, generate a Python reference library. And by the way, I've included that Python reference library in Unit 2 for us all. Rather than me sitting there and typing up a document, it did it for me in a few minutes, and I moved on with my day, right? And it probably did a better job than I would do. I did check it all. All right, so let's follow what the slide says here. By understanding the principles of deep learning you get some insights into what Gen AI is really kind of about. So I want you to look really carefully at some of these graphics here. It says Gen AI uses deep learning to create new material beyond the prediction and classification things that we would think. Now, it has the ability, basically, not only to create stuff that's valid, but we've talked about this too. It also has the capability of hallucinating or imagining stuff that isn't even possible. That's also kind of interesting in and of itself. But it is really truly driven by the deep learning models that make the Gen AI work. I know, like, the one thing that was popping around Facebook a few weeks ago was everybody had like their action figure in a box with their like tools or whatever. Did you guys, and a lot of people were doing it and posting it. I don't know if you guys were part of that wave. And there are models out there for building the prompts to do that. And that's just one of those goofy examples. Gen AI, so it is powered by deep learning. Notice what it does. It enables visual synthesis, text production, and virtual character creation. And some of these things are, I've been playing with some of the toys, and I'm kind of like blown away by some of them and underwhelmed by others, real frankly. I think some of them are really elegant. Some of them are got a long way to go, right? But you can imagine that they will get there. The fact that we can use a Gen AI engine to create content from scratch is pretty huge. Like, for example, if I ask the Gen AI to create an image illustrating that Gen AI is a subset of deep learning, which is a subset of machine learning, which is a subset of AI, and having generated a graphic to put on a PowerPoint slide, and it saves me the trouble of like bringing up a graphics tool and drawing it, and I just get an image and I just post it. What is the value of that? What is the value of your time is really what you start to ask. And then if you're gaining time, what are you doing with that time? Right? Are you being more productive, doing more work, or are you using the time to better your personal life? It could be both, right? You could have more personal time and be more productive. And I think that's a very exciting prospect, honestly. All right. Next slide here. All right. We're going to go through a series of slides here that talks about how these technologies are applied. And notice there's a discussion and hands-on activity. We're breezing over that stuff, but if we had a 4-hour class session, I would probably do those tasks, but time is precious. So I will also notate that when we were looking at these topics in the previous course, that we did talk about much of the same usages, but keep in mind that I do have people in here that are coming in cold without having taken that class. All right. So one thing machine learning is used for is detecting fake news, right? And this has been around for a while. And people have written algorithms which look at posts that get placed on social media or just out on the internet, and they're looking for certain cues in how the words are put together, or what information is provided to determine whether it's real or not, right? And a human, of course, could do this manually. And in some cases, you see people that post things, let's say on a social media platform, you go, that's not real. How can that be real, right? And sometimes you do it intentionally to be funny, so, and this has become a real issue, because what happened with Facebook this year, they decided to lift that. Now it's okay to post fake news on Facebook, basically, is what they're telling you. And so you got to be really mindful of the stuff that's presented to you. I'm going to quickly play this little video here, and I will apologize in advance if any ads play. I am not running an ad blocker here. This is going to come up in Chrome.
My name is Xavier Boix. I work at the Center for Brains, Minds, and Machines. In the lab, we develop technologies for machine learning and AI, and these technologies have an impact in society, and they can be used for good or bad. And we felt that we need to take responsibility on this, and this project is also a way to show students how this technology
Notice the neural network, you guys, right? Start to identify these things.
Technologies can be useful for social good. Nicole O'Brien was a grad student in the lab. She did the master thesis with us on fake news detection. After Nicole graduated, Sofia Latessa refined the results and accuracies.
The main goal of the project was to see if the machine could detect real news and fake news, regardless of source and author.
So first of all, we collected a data set of real and fake news.
So this data set had examples of articles that were factually correct and factually incorrect. Our next step is to train our machine.
And what we did in this case, in order to make it even more challenging, we removed from the training all articles related to Donald Trump.
So we fed that training set to the machine. We are saying, this one is fake, figure out why it's fake. This one is real, figure out why it's real. And from that point, we tested our machine.
So the machine has never seen an article that speaks about Donald Trump. And at testing, we only test with articles of Donald Trump. We thought it would be maybe an interesting result to check.
You read and a lot of what you see on television is fake. They realize it. The people are smart.
After we ran our analysis, we noticed that there is a subtle difference between the fake news articles and the real news articles. Within the fake news articles, it's shown that there are many hyperbolas and superlatives, and within the real news articles, there's a tone that's a little bit more conservative, and the verbs are more carefully chosen.
Yeah, we wanted to see if this could be useful for, not only an experiment in a lab.
So it's really exciting. We created a visualization component. So you can actually insert a body of text and it'll show you how the neural network is analyzing the article. And it'll say, this phrase is more fake and this other phrase is more real. Right now, fake news is extremely problematic. We've seen that it impacts society, we've seen that it impacts us politically, and overall, having misinformation spread online can have a huge societal impact.
All right. And I think that last little thing they said there is really kind of the key thing, right? So it's kind of like a bad rumor. People can spread fake information. And this is, by the way, this slide that I just flipped to, this link is the one in this slideshow that is no longer valid. I was trying it earlier and I tried to see if I could find it on their website. And basically they had the tool available online. You could try it, right? But no longer. So sorry, internet changes. Another machine learning thing are all the virtual assistants that we've been using. I want you to think about this. Virtual assistants have been around before this like Gen AI revolution started, right? I mean, a lot of us have been using things like the Google Assistant or Siri or Alexa or any of those types of tools on our phones in particular, more so than maybe our desktops, for quite a while. And what's the one on Windows? Cortana, thank you. I had to think about that for a second. But that one's been around quite a bit. And the actual tool that is mostly used, especially when you drive it with your voice, is the natural language processing, where you can actually just talk to your device, have it understand you, spin up its machine learning algorithm and do whatever it is you're asking it to do, whether it's like send a text message or look something up on the internet or map something or GPS it or whatever. Virtual assistants are used for all sorts of things. And okay, fine. I'll fire mine up here. Hey, Google, what's the weather out like right now?
Milwaukee, it's 57 and partly cloudy. Tonight, the forecast is around 51 degrees and partly cloudy.
Okay. Is that AI? Well, the part that actually is AI is the part that's understanding my voice and interpreting it correctly and then telling me the information I want. And hopefully it's doing it accurately, right? I mean, that's the thing. So virtual assistants are another example. This particular video, and I am skipping over this one, you guys should watch it. This is a video where they were demonstrating the Google Voice Assistant at a conference. And so the audio is not super great. But companies like this, when they spin up products like this, they show them off like crazy. There's a really cool video out there somewhere. So any of you like people who are Apple people, of when the Macintosh first came out and Steve Jobs was doing a demo of the new Mac This is in like 1984, by the way. And that had text to voice conversion on that computer back then. And he got the computer to talk to the audience. Oh my God, was that a hit? Right? It's like, oh my God, we're in the future. The computer's talking to me. Not really quite like what we have now. It was just reading words and converting them, to something audible. But now, some of these Gen AI engines it's almost like you are discussing with a person. Do you guys remember the replica thing that we played with in the intro to AI class? That was kind of creepy too, right? Where it created an avatar of yourself and you could interact with it and ask it questions. And depending on how much access you gave it to stuff, it could actually help you out. I played with it. I was not very, very enthralled with it, real basically. Here's kind of an interesting thing. For example, they give you a couple of questions here to work from. But has anybody here used virtual assistants or AI engines to help you create content? Well, by my encouragement, hopefully, right? Because I have been encouraging you guys when you are doing research for this class, yeah, you should use AI, right? You're AI students, right? That's kind of the way I see it. Here's another application of machine learning, sports analytics, right? And so like, I think of like, watching football this past season, and holy cow, if you watch like baseball or basketball, they got this stuff all over these sports now. They're really analyzing this stuff, and I just can't wait until all the bookies in Las Vegas get their hands on it, right? They probably already have their hands on it to do their analytics. But they use it, okay, not just for gambling, but also for improving the team, right? It's like, hey, every time we get in this situation, you do this and you mess it up. Let's try this instead, right? So once again, they have a couple of videos here. I'm not going to go through demonstrating these. You can watch these on your own, but I do encourage you to watch them. I'm just doing it in the interest of time so we don't waste time here tonight because we only have 20 minutes left. I think the basketball video is very insightful where they're mapping basketball players cruising around and their maneuvers. And then we have this technology. Remember, I forget what tool it was we played with that allowed you to do stuff like map out like the armature of a human being, record it, and then you can superimpose any body on it or study the movements on like what golf swing is more efficient or what way a basketball player or a football player throws a ball that's more powerful or more accurate, and they are analyzing these things. And the crazy thing is some of these tools are available for free. That blows my mind even more. So here's another little activity that we're skipping over. Another use of machine learning is recommendation system. So we go online and we go shopping, and it knows what I'm looking for. And I know that if I brought up Facebook right now, one of the first ads that would come up would probably be related to whatever stuff I was shopping for online most recently, right? And you guys have that effect often. Or if you go into like, I think these are mostly Amazon screens here, but if you're shopping online, and you're looking at a watch, it might bring up other watches, right, that are similar to that type of watch, or accessories that would work with that watch. Or you go over to YouTube, and all of a sudden the ads that are popping up here and inside, the YouTube videos are matching up with the content that you're searching for. It is not accidental, folks. Not at all. That is all done with machine learning algorithms. So there you see like uses of AI in practical settings. Another one that's kind of fun to play with, and once again, I'm looking at the time here and I'm going, I'd love to play with this during class time, but I don't think I have the time to, is the colorizing of black and white images. I might, how about this? If we have enough time at the end, I'll circle back to this one because I think this one's kind of fun. I do have some old family photos that are black and white on my machine here. And I'm talking from like the old country, back in Europe, to see them colorized. These there's two tools that they're pushing here. Um, both are available for free online, once again. And if you have some old black and white photos and you want to try them out, feel free to do so. I think they're really pretty fascinating, and it's a really kind of creepy, when you see an old photograph like this and then it's colorized and maybe it doesn't feel so old anymore just because of the color being there. But the fact that the tools are out there for free, they have two of them that they're pointing out. One is called Photo, right? And I'll click through and go to the links. You do have to sign in, but you can just simply drag and drop an image in here and it'll process it. I might circle back to this one. I think this is the one I liked better, if I remember right. The other one, same kind of thing. This one seems to be more app driven. So you would do this on your phone as opposed to doing it on your computer, right? I don't know if it works here in the browser. I did not try it here. This one I tried on the phone, but you can see what kind of results you might get by looking at the photos that are already there. You can just move the slider over what it started as and what it became. Does that make it look more modern? Not necessarily, but interesting nonetheless that those are out there and they're free. Blows my mind, right? In the past, I taught at an arts school for a while, web design, and I've seen people colorize images manually. It's tedious. The fact that you can go to a website, drop it in. How does it know what color to make things? Well, it has machine learning behind it. That's so that brick is probably yellow because it's in Milwaukee. All right, so let's take a look at once again at like some of the things that Gen AI can do. We've done this before too, but in all these different categories, the kind of stuff that you can generate with generative AI, it is really truly mind blowing that in all these areas, you notice anything that's text based or code based in particular, that's where most of the development happened initially. So that's where there are really huge advancements. There's a new branch of coding coming out right now. So this is a development, I think, since the last time we had class. It's like a few weeks. There's a new type of coding out there called vibe coding, where coders or programmers aren't necessarily sitting there writing computer code. They're working with an AI to write the computer code, and all they're doing is talking with the AI and giving it ideas and telling it to do a task, and then looking at the results going, okay, that was all right, let's try it like this now. And they're not doing any coding at all. And this has a name now. It's called vibe coding, and people are writing books about it. And some people in the industry are predicting that within 10 years, most coding will be done this way professionally. So does that mean we shouldn't learn how to code? I'll still say you still need to learn how to code, because how do you know if the code's good or not, or what's wrong with it, or how to fix it, right? Gen AI doesn't know everything. But the fact that this is happening, and then when you look at all these other areas, I mean, it is mind-blowing how much stuff is happening, and how quickly it's happening. Here's another tool example. And this one is one that you could QR with your phone if you want to go that way, or you can come here. I was playing with this one earlier, by the way. What this one allows you to do, and I'll just flip the slide for a second, you can generate highly realistic multilingual speech, other audio, including music, background noise, and simple sound effects. And so they do have a prompt in here, and I could just run the prompt. So they have input text. I'm not sure how well you guys can see that, and they have these words here. And if you hit run, it'll propagate it, and then it'll play some audio of a person talking, saying exactly that. And it's really, really creepy, by the way. I thought what might be more interesting is that we come up with something fresh. Like, And I might be pushing it too far, by the way. And I've never tried this prompt before, so this is not based on experience. Now, what you will notice it's doing is this is taking my prompt, right, that I just wrote, and it's generating audio. That's what the preset is set to do. You can task it to do a lot of other stuff. Once again, this is web-based and it's free and it works. I'm really curious to see what it just created. So let's see, right?
I'm hungry. I am angry. I'm sleep zombies. Angry. Angry.
Okay, well, that was really bad. By the way, didn't do it all. Yeah, and you know what? Let's. And I was trying to do all this background stuff. Maybe we should just do this. Let's run that algorithm. And you guys should play with this. And I really don't want to do a complicated example here, but I've seen demos of people doing like image and video generation with this tool. It's crazy, right? And it's all about what you write as the prompt. This one seems like it's going to run a little bit longer, right? So you see it has a little queue here. So I'm just trying to chew up the time talking while it's doing the rendering. There are, okay, so there's a guide here. So I'm telling it to giggle, and that's not one of the commands. Okay, so they have some example. I probably should have used one of the examples, would have been a little bit more interesting. I think this is really creepy that it can clone your voice. So yeah, that's kind of weird, right? Remember we watched some video about that was a simulation of Tom Hanks or something like that.
Hello, my name is Takis. I am Greek and can speak both English and Greek.
Okay. Apparently didn't get the giggle part. Yeah, that a little bit weird. Play with it, folks. Check it out. Be the first one on your block to try it, you know. So some of the things that you can do on this platform really go beyond the silly example I just did. But explore. If you guys create something really, really crazy cool, share it with the class next week if you play with it. All right. Let's dig into these topics now. We're in the home stretch here, folks, for the night, and I do plan on finishing. Why did this all happen? So why did machine learning and AI all of a sudden like explode? And part of it is because of all the information that came online that wasn't available before. I want you to think about this really carefully. The internet's been around since the late 60s, early 70s. People didn't really get on it though until the mid 90s, and then really in full force until the late 2000s, like when people started getting smartphones. All of a sudden everybody's walking around with the internet in their pocket, and now we have cloud servers and high bandwidth and devices in our pocket that we go everywhere with. So the data that comes with that is a big part of it. So there's a lot of data that is captured that now it has access to, so we can train it, right? In the past, that stuff wasn't online. If I wanted to get data to something, well, I'd have to like put it on a disk, right? And then put it in the machine and hope the machine could even handle the data. Now we can handle so much data, it kind of blows our minds. We have terabytes of storage on our laptops, maybe even our phones, right? We have high-speed processors and GPUs, and all that stuff is now here. That's the big thing. the hardware requirements are not going to diminish, and this is really kind of a big thing. Um, Things will keep changing, and we are going to need to adapt. So, for example, if we come up with algorithms that can detect spam email, this is the point here. Will the spammers get more creative about how they try to send you the spam? Yeah, absolutely. They're always going to try to find a way through. Now, keep in mind the people who are hackers also have access to AI. So while we try to prevent them from hacking us, they're trying to use AI to find better ways to hack us. So it's like spy versus spy or something, right? It's a challenge. The hardware has improved. Oh my God, significantly. I think of like the computer you owned 20 years ago, if you owned one, and the computer you own today. Heck, think about the computer you owned 3 years ago and the one you own today, and the capabilities and the power and the processing speed. We have this thing in IT called Moore's Law, which is this concept that this guy came up with, gosh, like 50, 60 years ago now, that he saw that with integrated circuit development, we were doubling the number of transistors put on an integrated circuit every 2 years. And it was more like 18 months, but they call it 2 years here. And that hasn't slowed down. We still are like whatever CPU we had 2 years ago, now we have one that's it's got twice the capability 2 years later. This is crazy, right? It's developing so fast, right? The other aspect is that we have chips now that are being designed to handle these tasks specifically. So NVIDIA with their GPUs often are used to do AI work. Apple's got on their new M series chips, they have machine learning cores built into the CPU. And that's what they're talking about here, the neural engine. And what it does is it learns what you do often on your machine and then prioritizes those tasks in ways that suit you. This is crazy stuff. This is science fiction kind of stuff. So why do those, Apple machines with the M chips perform so well? Because of those machine learning cores. They have GPU cores, CPU cores, and then I think that the silly M1 that I have here has got 12 machine learning cores. It's like extra CPUs. Yeah, that's the world we're in. We also have software acceleration. So we have AI has improved in performance because we have better code behind the AI, and that's been improved as well. There's also these libraries, and they have an example, of course, of pushing Intel stuff. And I think this one might be a quiz question, by the way, of a software AI accelerator from Intel called One API. So in other words, the people writing the libraries that create the API are doing a better job of it. So not only is the hardware faster, the algorithms are faster too. That's part of it as well. A lot of data, a lot of computing power, better algorithms. There's a lot of research happening in this area too. And basically what this chart shows is the amount of research papers written in higher level academia related to this topic. And this is like the early 90s, like nothing, right? If I only knew, right? And then now people, like thousands of people are writing research papers and doing their theses and doctorates on it. One of our instructors here at Gateway, Christian Herr, is currently working on his PhD in AI, and has to do the same thing. So one of the ones on the chart, it must be his. Another thing that's happening is this no code thing, right? And we played with some of these tools, so you can work with some of these engines online. You don't have to know how to write Python code and orchestrate all the algorithms. You drag and drop components, connect them together, make the right choices, and holy cow, you're building stuff and you don't even know how to code. Crazy. And free on top of it all. Really weird. You guys remember we worked with the Orange data mining thing. We worked a little bit with Teachable Machine. And there's also this other product called Lobe that we'll look at as well. All right. So home stretch here, folks. I know you guys are ready to go. If you do need to leave, just go ahead and leave. It is 9:50. If you want to stay for the last couple of slides, there's not much left, by the way. Okay, so what's Gen AI going to do to machine learning? So think about this crazy stuff. We have in place already a lot of AI tools, machine learning, deep learning, Gen AI, general purpose AI, or applied AI. And now that we can take AI to improve AI, this is where it gets really crazy science fiction once again, is that we can apply the generative AI tools that we've developed to improve the AI tools that we've developed. Think of the potential acceleration here. And oh my God, we're like walking into like, a Terminator movie. Skynet's going to come online any second and take us out, right? Hopefully not. But it is something that we are basically facing right now. One really weird little snippet I heard from somebody, and those of you that understand programming, right, which should be most of you, we understand this concept now of what we call object-oriented programming, where you create an object in computer code, and then once you've created it, you don't have to recreate it, you just reinstantiate it, you create another copy of it. So what if you were able to develop an AI and then tell the AI to create multiple copies of itself to solve a problem? This is what I'm talking about. So if I task, the 20 some people that are here in the room with me tonight to solve a problem, and I give you a task, you go solve that problem, you'd probably come back with 25 different solutions, or maybe like 2 or 3 major solutions and a bunch of minor solutions, right? The point is you all come up with different answers. If I make different versions of an AI, will it all come up with the same answer, or will it come up with a bunch of different answers? And if that's the case, can we take an AI, replicate it, ask it a question, and have it come up with 1,000 solutions? Could we cure cancer in a day? This is the kind of like weird stuff that we're entering into. I know it sounds like crazy thoughts, but we are moving into these eras, and it is us, the people learning about how to do this stuff, that will orchestrate this, right? So you guys are in the right place. We are the ones that are going to steer the future, just simply because we have the knowledge of what's going on behind the scenes, right? So, all right, folks, this video ends here.